Welcome to the University of Buffalo, where a team of students called SpaceBulls is hard at work designing and building a planetary rover. The team is made up of 11 students from various engineering departments at UB who are working together on this multi-disciplinary system. The rover is for the Rascal Robo-Ops competition that takes place at the Johnson Space Center in Houston, Texas. The rover must complete a series of tasks while navigating the Johnson Space Center's rock yard. The team sees this competition as an opportunity to apply the topics of their education towards a practical implementation. Let's see how the team plans to tackle the challenge.
This uses a rocker bogie suspension mechanism which is better than any other walking or wheel mechanism. It also uses a MEMS-based inertial measurement unit which is used for the body rates measurement.
The system has 6 independent drive wheels with 2 steering motors in the front and back. These drives would be arranged in the form of a master-slave control.
This is a 7 degrees of freedom manipulator that will be using on the rover to pick up the stones. I'll give the XYZ coordinate for the end effector and it has to reach there. This is the final configuration that the manipulator will leave.
Since it's a teleoperated robot, communication plays a vital role. The commands and sensor data have to be communicated constantly between the rover and UB. You have to see it to believe it.
Since the rover is to be teleoperated, we need to be sure we see what the rover sees. To that end, we put a camera on the rover and we're streaming the video back to a base at UB. The streaming is done on an Ubuntu machine with the FFmpeg server. The resolution of the video is dependent on the internet speeds. The video has to be smooth and it has to be real time. Let's see a demo on how the manufacturing process is going.
All the good designs have to be realized to perfection. For this we use CNC machine for the critical parts and manual machine for other parts. All this space age technology is meaningless if it does not have a public commitment. And that's what our team is going to do right now with the education and public outreach program.
We could embed the excitement and need for space exploration in the budding minds during our education and public outreach in the University of Buffalo and the Buffalo Museum of Science.
While our team develops the rover for testing on Earth, there are still many challenges to be addressed for deployment on other planets, such as harsh environments and supply of power to the rover. There is ongoing development in areas concerning planetary exploration. Some examples include composite materials, efficient power systems, communication, and navigation. It's important to keep pushing the limits of what is capable. As the presence of humans on Earth increases, we will realize issues of resource depletion and overcrowding, providing motivation to explore other planets. Space is the next final frontier, with its exploration lending to the interest and imaginations of all mankind.